Hello guys, today we will solve a mechanics of material problem with the help of Solidworks and also learn how to do simulation in Solidworks. The program is quite simple. The program tells draw the shear and bending moment diagram for a simply supported beam A beam of a span L subjected to a single concentrated load P at its point C. So force be applied at midpoint of beam, and in this question the material we use for beam is not defined, and what type of beam we use is also not defined, and length is also not defined. So we assume the length, force and beam and also force. So here is two fixture A and B. Fixture A not allowed translation in either x direction or y direction, but fixture B allow translation in x direction and not allowed in y direction. And the shear and bending moment diagram of this program is this one, and this is the shear force diagram, and this is the shear moment diagram. So now go to the SolidWorks and solve this program and draw the shear and bending moment diagram of this program. So go to the SolidWorks. So now go to the front plane and select the option line. So we take the length of the beam is 200 mm. So now go to the option smart dimension, and now we go to the option weldment. So go to the option insert, select weldments and select a structure member. So here we give the dimension of line in mm. So we select the standard ISO and type it a square tube. If you want to change the type of beam, so you can change. Here is a many type of option. If you want to import your own beam, so you can also import and change the type of beam. Also you change the size of the beam. Here we take 20 cross 20 cross 2. If you want to change the size of the beam, you can change. And now select the both line and select OK. Now go to the option simulation and select a study advisor and select new study and select a static. And now we apply the material of beam. So go to the option apply material. Here you see a lot of material: steel, iron, aluminum alloy, copper alloy, titanium alloy, zinc alloy. Lot of options available. So now we apply the steel, and in the steel we apply allow steel. Apply and close. Now you see the color of the beam is changed. Now go to the option fix advisor and select fix geometry. So here we cannot choose the fixed geometry because fixed geometry allow the option bending. Now you see in here, but in this case we do not apply allow bending, and we in this point we do not have any type of moment, neither this point neither or this point also, either this point or either this point. So go to the option use reference geometry and select the point this one and go. This is the direction of applied force, this option. So go to the and select the this phase. And now you saw there uh, there are lot of options, translation and rotation. So this point do not allow the translation in either pi or x. So this is the x direction, this is the x direction translation, and this is the, so this is not that direction, so this is the y direction. And so go and select OK. And same here, this point allow the translation in x direction and do not allow translation in y direction. So go to the fixer and select fix geometry. Now go to the option use reference and select this point and select this face, and now you select this line. Sorry. Now select this line and select OK. Now we apply the external force at these points. Now select this point and select the direction. So we want in this direction, and also we take the magnitude of force is 100 Newton. And now select OK and go to the option run this study. So this is the displacement of this beam when we apply the force 100 Newton, and our question tells the shear and bending moment diagram of this beam. So now go to the option result and select define beam diagram and select the shear force in direction 1 and select OK. So this is the diagram of that question. This is the diagram of this question, shear force diagram of this question. And now go to the option define beam diagram and select the moment about direction 2, because when we apply force in direction 1, then moment is in direction 2. So select OK, and this is the diagram of shear moment. This is the same diagram. So now thank you guys.